The production of atomic hydrogen. How we can produce the atomic hydrogen. So there are so many processes which we have already studied that we can produce the atomic hydrogen with so many methods, and it is readily available in our nature in with in the form of water when react with oxygen. It is as a source of energy, right? Glucose, sugar, fructose, anything, whatever you see the sources of energy, hydrogen is there. Okay, so the atomic hydrogen is produced at a high temperature in an electric arc or under ultraviolet radiations. This is like an electrolysis process. Electric arc is like a setup of electricity where we can produce the hydrogen. Okay, hydrogen orbital is complete with one s1 electronic configuration. We know this thing that, but it does not combine with almost all the elements. It can only combine with which it can share its electron. Losing a one electron at that time, we used to put positive sign. Gaining of electron to form H negative in case of LiH being a metal. It's just accept the electron because Li is more reactive and more stable than hydrogen, and it enforces the hydrogen to accept that electron. So that is why we used to put H negative whenever the hydrogen gives the electron. By sharing the electron with the single bond, we know this thing that atoms used to combine together by sharing their electrons, and at that time the bond formed that is known as the covalent bond. Okay, so now we'll talk about the specific thing, the reaction of dihydrogen, how the dihydrogen react with the other elements to form hydrides. Okay, so first reaction with halogen, it reacts with halogen to give hydrogen halides, while the reaction with fluorine occur even in dark. With iodine, it requires a catalyst. Okay, means it can react with halogen. Halogen is fluorine family. Fluorine, chlorine. These are the halogen family, 17th group. So it can react with the halogens and form hydrogen halides. Reaction with oxygen. Dihydrogen react with oxygen and form water. We know this thing that, and this process is exothermic. Means this process goes on with the liberation of a large amount of heat. Whenever the hydrogen oxygen combine together, they form water. Reaction with dinitrogen. With dinitrogen, it forms ammonia. Okay, ammonia. This is the method of manufacture of ammonia by Haber process. Whenever we react the dihydrogen with ammonia, so we can manufacture means dihydrogen, and we can manufacture ammonia easily, and that is the process which is accepted by the Habers, and the Haber process includes all the steps. So here are some reactions with which we can learn. Reaction with halogen, for example, X is an halogen, so HX. So H2X2, it will form X. Okay, and halogen is fluorine, chlorine, bromine. I have already told you. Second reaction with oxygen, it react with the oxygen and form H2O. H2O is the water molecule, and this minus shows sign shows the liberation of heat in the presence of catalyst. And next is where the last point which we have discussed, the reaction with dinitrogen. It react with the dinitrogen and form ammonia. For example, 3H2 gives N2 and form 2NO3 in a specific condition, that is 673 Kelvin temperature and 200 atmospheric pressure, and a specific catalyst, that is iron. And the liberation of heat will be there because this is also an exothermic reaction. Okay, so this means this is the process which was adapted by Haber's in his process to produce the ammonia. It can react easily with metals. It react with the metals to form organic compounds. It can, like it metal hydrides, sorry. It can react easily with the metals to form metallic hydrides. It also can react with the organic compounds. First, the process is hydrogenation. Hydrogenation means the hydrogenation of vegetable oil using nickel as a catalyst, given edible fat is margarine and vanaspati ghee. We used to eat vanaspati ghee, so that is the reaction of hydrogen. Okay, that is also known as hydrogenation. Next is hydroformylation. Hydroformylation of or fine yield aldehydes with further undergo reduction to give alcohol. And this there is also a process when it react with the organic compound to produce alcohol, and that is known as hydroformylation. Uses of dihydrogen. How the dihydrogen is used. First, the largest single use of dihydrogen is in the synthesis of ammonia, which is used in the manufacture of nitric acid and nitrogenous fertilizers. In 8th class, we have studied that hydrogen is used in the nitrogenous fertilizers to enrich the soil with the minerals. Okay. Dihydrogen is used in the manufacture of vanaspati fat by the hydrogenation of polyunsaturated vegetable oil like soya bean, coconut seeds. By these seeds and soya bean, and dihydrogen is used to manufacture the vanaspati fat, the vanaspati ghee, which we used to eat as like edible oil. Okay, it is used in the manufacture of bulk organic chemicals that with a particular method. With a particular method, we can manufacture bulk of organic chemicals, particularly like methanol. It is used in the preparation of hydrogen chloride, a highly useful chemical. Hydrogen chloride is also prepared by using dihydrogen. In metallurgy process, it is used to reduce heavy metals oxide to metals. Metallurgy is the separation of metals from their oxides. Okay, and at that time, hydrogen is used to reduce the metals and production of pure metals. Atomic hydrogen and oxy-hydrogen touches find us for cutting welding process. Atomic hydrogen atom produced by dissociation of dihydrogen with the help of electric arc are allowed to recombine on the surface to be weld to generate the temperature of about 4000 Kelvin. So the welders, which we used to see some sparking light. Whenever we used to weld something, we used to see a welder welding the metal objects. So there the high dihydrogen and oxyhydrogen torches are used. Okay, it is used as a rocket fuel in the space the high because of the high calorific value. Means hydrogen has a high calorific value. Because of this is used as a fuel in rockets and space and for space researches. It is widely used in the manufacture of metal hydrides. Metal hydrides are manufactured by using the dihydrogen. Dihydrogen is used in the fuel cells of generating electrical energy. It has many advantages over the con- one bit. It's like conventional fossil fuels and electrical power. It does not produce any pollution and generate power per unit mass of the fuel in comparison to gasoline and other fuels. Means this is the best fuel which like after burning of hydrogen there is no residue left behind. So that is why this is known as the best fuel because or we can say the ideal fuel because it generates a large amount of heat as well as do not leave any unburned particle in the atmosphere. So this is a cleaner fuel also. Now hydrides. Dihydrogen under certain conditions combine with almost all the elements except noble gases to form a binary compound called hydrides. So these hydrides are classified into three categories. First, ionic hydrides, saline or saltlike hydrides, means like ionic compounds which contains hydrogens. Like second, covalent and molecular hydrides, and third is metallic and non-stoichiometric hydrides. Okay. Ionic or saline hydrides, the compounds of dihydrogen formed with most of the S block elements, which are highly electropositive in characters. Okay, the lightest metal hydrides such as LiH, BeH2 means all the elements present in the S block combines with the hydrogen and forms the hydrides, but ionic hydrides. Okay, the ionic hydrides these are crystalline means they have specific structures and crystalline characteristics, non-volatile, non-conducting in solid state. They can conduct electricity whenever dissolved in water or in molten state. However, their metals conduct electricity on electrolysis, liberate dihydrogen, the gas at anode, which is confirm the existence of H positive ion. Saline hydride react volatilely with water producing the dihydrogen gas. The litmus hydride is rather unreactive to moderate temperature with O2, Cl2. It therefore used in the synthesis of useful hydrides. Next is the covalent or molecular hydrides. The dihydrogen forms a molecular compound with most of the p block elements. The covalent or molecular hydrides formed whenever the dihydrogen combined with the p block elements. For example, CH4, NH3, H2, HF. These are the uh, covalent hydrides. Okay, being covalent, they are very volatile. So molecular hydrides are further classified uh, into many forms on the basis of their Lewis dot structure bond present. So first is electron deficient, means they act as Lewis acid, means electron acceptors. Second, the electron precise. All elements of 14 group of the combine like CH4, they have tetrahedral in geometry and a specific they don't have any lone pair of electron or they do not accept any electron means this is the stable molecule. They do not require any electron and have any unpaired electrons. Okay, electron rich hydrides, they will behave as Lewis bases, means that they are the electron donors. For example, like and in NH4 the lone pairs of electrons are there, means they contains the lone pair of electrons, so that is why they are known as the electron donors. Next is metallic and non-stoichiometric interstitial hydrides. They are formed by the D block or F block elements. The metals of 7th, 8th, and ninth group do not form the hydride. These hydrides conduct heat and electricity not as sufficient as their parent metal do. Means, for example, that the elements of D block are good conductors because they comes in the category of metals, and they are like good conductor of electricity, but their hydrides do not conduct electricity as their parents do. They are almost always non-stoichiometric, being the deficiency of hydrogen, for example, like LaH82 and ZrH1. There are so many like hydrides, they are non-stoichiometric. The law of constant composition does not hold good. Recent study has shown that except the hydrides of nickel, like cesium, arsenic, and other hydrides in their class, their lattice difference from that of their parent metal. Parent metals have their different lattice, but they shows the hydride shows different lattice. Okay, the property of absorption of hydrogen on transition metal is widely used in catalytic reduction, the hydrogenous reaction for the preparation of large number of compounds. Some of the metals like PD and PT are accommodate a very large volume in the hydrogen and therefore can be used as its storage media. So this property has high potential of hydrogen storage means as a source of energy.